first of all, thank you all for letting us come into your homes and share your homes, and during these trying times, hopefully try to get back to some normalcy with a nice CE here. And I will present, it'll be sort of a double-edged sword. I will present the past and sort of the current retina treatments with a lot of basic reviews and what we've been doing and what we've done in the past. And then I'll kick it over to Dr. Wyckoff and others who will go into the future of retina and what is coming and what we can hopefully look forward to. So thank you all for coming. Also, if you have any questions, they should raise their hand on the screen, that is. So just an introduction, I think a lot of us, a lot of us at Retina Consultants of Houston, Dr. Binns, Dr. Brown, Dr. Chin, Dr. Fish and Henry, Dr. Rosa Kim, myself, I'm James Major, Dr. O'Malley, Dr. Scheffler, Dr. Wong, and Dr. Shaw. And we're all here basically tonight. So if you have any questions for any of us individually, please say so. Good. And this meeting, this CE event is sponsored by the Greater Houston Retina Research Foundation. That's a 501c3 nonprofit organization. It is a separate financial entity from the Retina Consultants of Houston clinical entity. And so this is our foundation that we use to promote vision and vision gain and research. And so it is tax deductible, as are donations. And again, it's a separate financial and clinical entity from Retina Consultants of Houston. And it's a wonderful, wonderful foundation, Greater Houston Retina Research Foundation, and it is our sponsor tonight. We have 14 locations throughout the Greater Houston area. Look on that map, and there's probably one near you anywhere you are. We've got them all over town. There are two to highlight here. One is Pearland. If you notice number 10, Pearland on 288, just outside the Beltway, that is opening this fall, maybe September or October. And that's going to be a wonderful new office that will serve areas south of the city and sort of sandwiched between our Space Center Pasadena office and Sugarland. Sugarland is the other one I really wanted to mention and highlight because it is a brand new office. It's essentially on 59 and University and on Brisbane Court, just off 59. It is large, it is expansive. It just opened up about 2 or 3 weeks ago, and it is fantastic. So all the offices for us are the same. We have fantastic equipment, we have fantastic staff, and what we think, we've always said that we sort of differentiate ourselves from others in that we present at major clinical trials, we present at meetings, so we stay on the forefront and on the edge of both clinical and sort of research retina, and hopefully in our group, those two entities combined to give you overall better clinical care. We also only take the best folks, and speaking of that, we have 2 new people arriving probably in September. That is Dr. Sagar Patel and Dr. Wynn, and they will be at various offices around town, but we're excited to have 2 new doctors, Dr. Patel and Dr. Wynn. All right. So you're going to hear Sarah Barbatano's voice, and she will go over some of our new platforms that we're excited to have that are concerned with sharing patient information back and forth, HIPAA compliant measures, and sort of how to do that. But we're really excited about this new platform that essentially she created to help us better serve you and your patients and honestly communicate a little better back and forth. Sarah, take that away.
Good evening. Thank you all for joining us. Last year, we talked a little bit about how we were going to add a feature to our website that allowed you to upload your patient records with your website referrals. And that way we'd have all the information we needed to see and treat your patients. And we are happy to announce that that feature has gone live on our website. If you go to houstonretina.com and go to your doctor section and refer a patient, you can attach photos that you've taken in your office. You can attach medical records, and those will be safely transferred to us, and we'll be able to upload it into our patients chart here at Retina Consultants of Houston. Another new feature that's coming soon, we're rolling it out to everyone in the next few weeks. We're calling it our RCH image portal. Many of you receive faxes from our office with your patient letters and images, black and white. They're not always the best quality. And we pride ourselves on the images that we take in our office. And so we're very excited to be able to share our images with you electronically and in color. It's very simple. All you do is create your account, and you'll be able to receive your correspondence from us just like this in color. You'll be able to zoom in on the images and really see what we're seeing when your patients come to see us. We're really excited about it. It's something we've been working on for a really long time, and we hope that you find it beneficial. There will be more news coming on that front soon. This is kind of a rendering of what it looks like. As you know now, these letters come from us in black and white, but here it's shown in color, and it's a PDF, so you can zoom in on the image and it doesn't distort. You could download it and upload it into your own EMR. And it's just a really awesome new feature that we're very excited about. And with that, I'm going to turn it over to Dr. Wyckoff, who is going to share some words with you.
All right, good evening. Thank you for joining us virtually. It really is a privilege to be here with all of you. As we go through this, please feel free to submit questions or comments through the chat function. You can also try to raise your hand and we can call on you and see if you can speak up at any time as well. So over the next 5 minutes, I'm going to give you our perspective on adapting to this crazy world that we have all been thrown into with COVID-19. And to go through that, I put together some images mostly of our clinics. But the first slide is, of course, from a retina perspective, all of our patients are in the highest risk demographics, right? We've learned from a lot of publications in this space that the older you are and the more comorbidities you have increases your risk for both morbidity and mortality from this virus. And so this has been very real to us, as it has been for you since day one. We've confronted a lot of fear among our patients, and we've taken tremendous steps to try to minimize that and to continue to deliver the care that is appropriate. So in that regard, really two main factors came up immediately when this started. We as a group sort of huddled multiple times, late nights, early mornings, and sort of came away with two concepts that we continue to live by today. The first is that safety is paramount, right? Safety for our patients, safety for the physicians, safety for our staff, safety for our families, safety for everyone in the team. And we'll walk through exactly what we've done to try to achieve that. But the second objective of the two that we set out to achieve, which I think we've done a remarkably decent job at, is that unfortunately and fortunately, retina is the kind of care that unfortunately can't be just shuttered from our perspective. These patients have blinding diseases that need to be continued to be cared for. We continue to do surgeries through the entire time. We continue to treat peripheral retinal tears that were acute. We continue to give injections for patients with blinding retinal diseases throughout this entire process. So we have learned a lot over the last 4 to 8 weeks, and it's been a very trying and exhausting time for all of us, our staff most of all. Some of the takeaways that we've learned and that we are continuing to implement are listed here. Again, they all revolve around safety. So we do a lot of pre-screening. So on the far right of this image, you see what we've set up at each one of our clinics, which is a screening booth where all patients coming in get a temperature. They get the standard COVID questions that they answer that we document in their chart electronically. And every patient is given a mask. Only patients are allowed in our clinics at this point. We certainly allow exceptions when there's someone that needs help with transportation or with language barriers, but we try very hard just to allow patients in, to allow spreading them out as much as possible, both in time and space. In pre-screening, we're also screening on the telephone. We're calling most of our patients before they come in to know what to expect. And again, PPE is given to all patients and all staff. Our staff are masked as well as our doctors 100% of the time in clinic. When they eat or drink anything, they try to isolate themselves and do that as efficiently as possible. Contact precautions are taken meticulously seriously. We wear gloves at all times and wash our hands routinely. Everything is sanitized between patients thoroughly. And again, we're trying to spread patients out while they're in clinic. Here's a couple images of around town of our staff and doctors. You have Dr. Kim in the middle, Dr. Richard Fish at the bottom, Dr. Matt Benz on the top left, and Dr. Encore Shaw. Again, probably the most important people in these pictures are, again, the staff that are supporting these doctors that make our work possible. You can see these plastic shields that are covering the faces of many of our physicians and staff members. all of our staff have been given one of these to use when they're in close contact with patients. Here's what this looks like in real life. Here's a couple of our staff engaging with patients over the last month or so, trying to minimize any droplet transmission, both from patients to staff and doctors, as well as from staff and doctors to patients. Here's what our clinic looked like on the left, as I'm sure many of yours did 2 or 3 months ago. And here's what our clinic looks like on the right. Significant spaced out. We take these precautions extremely seriously through all of our clinics. Here's a couple more clinics showing these spaced out issues. So the very last slide I have to talk about COVID is shown here. You know, I think at the beginning there was this unfortunately false sense of hope that this would be over in a short period of time. It's clear that this is going to be a prolonged disruption for all of us in eye care, and we are in this together. And so as much as we can, we are going to continue to provide masks for all patients when they're coming in. We're going to continue to space them out. We're going to continue to be as efficient as we can when patients are in clinic, knowing that retinal diseases are something that cannot take a holiday for these blinding diseases. The other interesting side of this is that we're seeing tremendous expansion in the research side for remote monitoring and telemedicine. It's actually it's kind of sad that we as a field have such amazing imaging that you guys all use and we use every day, and yet we have nothing at home to take an OCT or a fundus photograph. I do think that that's going to change in the relatively near future, and I think that this will be an impetus to really transform how we extend the care that you all give and that we give from our clinics into the home, allowing us to collaborate more and more over the years to come. So with that, I will hand it back to Dr. Major.
Screen. Got it. Okay, I am back. Thank you, Dr. Wyckoff. Excellent. So let's take it in. And so again, I am the bread and butter guy. I'm going to give you what we're doing for the basic retinal diseases, diabetic macular edema, diabetic retinopathy, some of which you've heard before, and hopefully we can refresh, and some of which maybe you haven't heard before. But it's essentially what we have been doing, what led us there, and what we're currently doing, and a little wet and dry macular degeneration. And hopefully some stuff you can hang your hat on in the clinic when Miss Jones comes in and says, well, I have dry macular degeneration. Am I going to turn wet? And you know, I'm going to need an injection. What are we going to do about that? What does that feel like? What can I expect? So, but before we do that, we've got something that's too hot off the press to ignore. So 2 days ago, on a wonderful day, May 12th, COVID-19 retinopathy, there was a paper in the Lancet journal that said, listen, here's some findings, some OCT findings of essentially about a dozen patients, 11 of which were healthcare workers, mostly doctors. It came out of Brazil and said, look, these are OCT findings of patients with COVID-19, and here's their retinopathy. By the way, these patients had no visual symptoms whatsoever. Vision was great, no itchy, scratchy eye. You know, probably the most common manifestation that we really need to worry about in terms of COVID-19, in terms of an ocular manifestation, would likely be a conjunctivitis. So something very similar to an infectious conjunctivitis, a pink eye with red dilated eye. They'd come in with maybe itchy, scratchy, something fairly minor, but that is probably like a viral conjunctivitis. That would probably be the most common manifestation. This is probably exceedingly rare, but what I want to point out is if you look at the OCT, right near the ganglion cell layer and inner plexiform layer, so it's in the inner retina, right close to the vitreous, these small little white hyperreflective areas, very in the inner retina, essentially in the inner plexiform layer, right close to the ganglion layer. So, Dr. Henry, are you there?
I'm here, James.
I want to know, Dr. Henry is our uveitis expert and an expert on anything infectious and non-infectious and inflammatory in the eye. Dr. Henry, what do you think about this?
So, James, I'm going to be honest, I actually don't buy this. And I don't buy this. And actually look at the OCTs. What you're actually seeing are cross-sectional scans that are through normal blood vessels. So actually the capillaries and arterioles are actually what we're seeing as the hyperreflective foci. So I think this may have slipped through the medical literature based on COVID being kind of a new novel thing. I think we're actually not seeing a new finding. We're actually seeing normal blood vessels.
Thank you. So maybe not as hot as we thought it was, says Dr. Henry. So we'll wait to be seen. I just wanted to throw that out to you, something to look at. It literally just came out 2 days ago. So thank you, Chris. Okay, here is a patient that Dr. Fish, are you there? This is a patient that comes into your office that's referred in. They have a lot of diabetic macular edema, as you can see, and subretinal fluid on their OCT. You can see the back of the posterior hyaloid face. They do not have a PVD yet. They've got their 20/80. They can't drive to work anymore because the other eye looks like this. So Dr. Fish, you know this person's likely going to need injections. What do you tell this patient about what they're going to need in the future? What do you tell them about sort of the initial process of receiving injections, and what can they expect?
Well, over the years, I've just sort of learned, a handful of very good standard talks, and I speak a lot in analogies. So retinal detachment is water behind a sheet of wallpaper, or, anti-VEGF injections, a little bit like chemotherapy. So when you sort of put this in an analogy kind of way that patients can kind of clutch onto that, I think they get it. So I usually say, okay, you're going to need what's called anti-VEGF therapy. This is a series of injections. And then the very next thing I say is, I promise with it, we won't hurt you. We'll numb you up really well so you don't feel anything. And you got to come in initially once a month to get these injections in a similar way that if you had certain types of cancer, you'd have to have multiple series of chemotherapy sessions. And it's not just one or two. This is a long-term commitment, so you have to kind of strap in for the long haul.
Dr. Fish, I'm getting a bunch of injections. Will I be able to drive again? Can I expect improvement? Or are you going to keep me the same?
The majority of patients who start out in this situation with a really swollen macula like you have, we can expect vision improvement and, more importantly, stabilization. But it's very reasonable to expect that unless there's severe damage to the small blood vessels in the, I might not tell them about the FAZ, but I would say unless there's severe damage and loss of the blood supply, we can expect an improvement in your vision.
Okay, good. Well, before we even get into DME, this is one of my favorite slides because it really illustrates the problem that diabetes and diabetic retinopathy has become and will become in the future in the United States. It really is an epidemic of diabetes and diabetic retinopathy. And we're seeing more and more of it in our clinics, and the disease is worse and worse. And so the darker orange or red is a higher prevalence, say 9%. So this is the prevalence of diabetes across the United States in 1994. And as we move through time, look at the states become redder and redder and more orange. In other words, even 6 years ago, it's essentially all of the southern states there's a greater than 9% incidence of diabetes, many of which have diabetic retinopathy. It's just a huge, huge problem. And this also reflects the worldwide incidence to some degree too. It's not just the United States. There's a pandemic of diabetes as well as COVID-19. So when someone comes in, most of the time we see type 2 diabetics. And if you'll notice the little boxed in square, so about a third, 20 to 39% of patients when they walk in your office at diagnosis will have some type of retinopathy, even if it's mild diabetic, mild non-proliferative diabetic retinopathy. And unfortunately, some we see have never seen a doctor. They have a tractional retinal detachment. They have terrible edema, like we saw earlier, and they have a lot of ischemia and the subsequent pathology that goes with it. So things to ask your patients when they walk in the door with diabetes before you even get to the retina. What is your hemoglobin A1C? Is it rising? Is it falling? As I described to my patients, look, your diabetic retinopathy scale, 10 being terrible, 1 being nothing, maybe yours is a 5, but that number is movable. If your hemoglobin A1C continues to rise and you don't control your blood sugar, that number 5 is going to rise to a 6, to a 7, to an 8, and we're going to get into problems. But for every point you lower your hemoglobin A1C, can you take me from a 10 to a 9 or a 9 to an 8? You essentially can cut your diabetic retinopathy in half. There's a lot of gain to even just a little bit of hemoglobin A1C reduction. What is their blood pressure, cholesterol levels, and very, very important, smoker. And that also obviously becomes important for your wet and dry macular degeneration patients. even if they say, look, I smoke 2 packs a day. I'm not going to quit, doc. No way I'm going to quit. I've been smoking for 30 years. Well, can you give me 1 pack a day? Because even a smoking reduction versus a cessation also shows clinical benefit in these patients. So, wide field angiography, which we have at all our clinics, has become the gold standard now. We used to use these circular fields for research, and you can see they get the posterior pole on fluorescein angiogram, but you get the edge of you're missing a whole lot that's out in the periphery. So, offices or practices that don't have this, I think, are really missing out. This is a fundus wide field, Optos wide field fundus angiogram. You can really see that most of the action in diabetes and in other diseases is in the periphery. Look at the ischemia, the neovascularization elsewhere that you have temporally and superior temporally. That's where the action is. Same with this patient. You'd essentially miss everything. Look at that neovascularization elsewhere, nasally in this left eye, and look at all that ischemia peripherally. Peripheral lesions. Certain studies have said, look, the more peripheral diabetic retinopathy lesions you have, and you can look at them even in the pictures that you get in your office, they elevate the risk of significant worsening of diabetic retinopathy 3 to 5-fold. So the patient with a bunch of dot blot hemorrhages and MAs and things that are arising in the periphery, that's a big red flag warning sign. So, ischemia or hungry retina is what secretes VEGF. So the more dead or hungry retina you have, the more VEGF or vascular endothelial growth factor that you have. When that rises, it causes a breakdown in the blood retinal barrier and causes edema or overwhelms the capacity of those vessels. They then leak and give you diabetic macular edema. So this is an example of diffuse edema. Some patients have a little small area of edema that's off the fovea, in the macula, sort of off to the side, and we still treat those patients, and it's acceptable to treat them with focal laser. So they come in the clinic, they get a little light laser. It's not central, it can't be done centrally, and they tend to sort of hang on or do well. But what we really do is give these patients injections. And the EDTRS, which is a very old study now, showed that, look, this focal laser can reduce risk of vision loss. But if you look at the red, only a small number of patients had moderate, really there's no visual gain. You're really just sort of holding on to what you have. So the visual gain came about in the area of anti-VEGF, and that is the gold standard of care now. So typically a patient comes in, like Dr. Fish mentioned, and has this subretinal and intraretinal fluid. They get a series of monthly anti-VEGF injections that are then spaced out, tailor-made to what that patient's edema and vision and characteristics are. And hopefully we can flatten that retina and lead to greater, which leads to greater vision. But these injections kill 2 birds with 1 stone. 1, they hopefully flatten the edema, leading to vision gain. And number 2, which we'll talk about next, they reduce the diabetic retinopathy severity scale. In other words, the number that I mentioned earlier, hey, Mrs. Johnson, you're a 6 out of 10. Let's make that a 5, a 4, a 3, which is also aided by the anti-VEGF medications. Yes. So any questions that you have there, number 1, save them for the end. We're going to save plenty of time at the end. Type them in. And as I talk, it's hard for me to see those questions if some of my fellow retina consultants, diffuse doctors can answer those if can. They're hard to see on my screen as they pop up and roll. So save your questions, raise your hand, and the fellow RCH doctors answer them as we cruise along here. We won't get too much into it, but medication options, these are the anti-VEGF options. Just so you know them by name. Bevacizumab is Avastin, been around a long time. Ranibizumab is Lucentis. Aflibercept is Eylea, the newest of the drugs. And the last 2 you see are triamcinolone and dexamethasone. Those are steroids. Those are not anti-VEGF, although corticosteroids do to some degree kill 2 birds with 1 stone, so to speak, and they do inhibit VEGF. And these molecules differ in their size, their shape, and essentially their safety profile, at least their potential safety profile. So patient comes in, you look at their posterior pole, looks pretty good. But when you get that wide field FA, there's a ton of 360 ischemia. So you can just imagine all that dead or ischemic retina secreting VEGF that you want to inhibit, causing that neovascularization elsewhere and causing that diabetic macular edema. So this is the diabetic retinopathy severity scale that we talked about. And to keep it simple, just imagine it essentially 1 through 10. 1 or 0 is diabetic retinopathy absent. They look great. And then 10 or higher is high risk PDR. And the important breakpoint is when you get to, say, a 7 or so, you've got proliferative diabetic retinopathy. You have new blood vessel growth. That new blood vessel growth, as I explain to my patients, are at risk for breaking and bleeding. If they break and bleed, you get a vitreous hemorrhage, then we might be talking about surgery potentially, and your risk for vision loss significantly skyrockets. So this is the scale in numbers essentially of mild non-proliferative diabetic retinopathy, moderately severe, severe, and then mild proliferative diabetic retinopathy, and forward as you get into tractional retinal detachments and things like that. And so it's been a research interest of Dr. Wyckoff's, but really one of the thresholds is, imagine if a patient comes in with severe non-proliferative diabetic retinopathy. Forget their diabetic macular edema for a second, and you can give that patient injections and decrease their number, make them go from a severe non-proliferative patient. They never cross the threshold into proliferative diabetic retinopathy. Maybe you make them moderate or mild. You perhaps have increased that patient's overall productivity, their ability to go to work, their ability to avoid surgery. And it is a very, very big deal on a huge sort of nationwide socioeconomic sort of level as well. So preventing patients from turning into PDR, because once you hit severe non-proliferative diabetic retinopathy without any treatment, basically your chance of turning into proliferative is 50-50. In other words, you see Mrs. Johnson in 2019 with severe non-proliferative diabetic retinopathy. She doesn't come back for a year. There's about a 50-50 shot she has crossed that threshold into proliferative diabetic retinopathy. So very important. And the VEGF drugs, for the most part, Lucentis, is approved, FDA approved for the reduction of diabetic retinopathy, to reduce the diabetic retinopathy severity scale. Here's a quick example. Patient comes in with high risk proliferative diabetic retinopathy, already has sort of a little subhyaloid vitreous style hemorrhage with dot plot hemorrhages and MAs everywhere. They get a bunch of injections and wham, it looks like they don't even have diabetes. It's incredible. They go from high risk PDR after essentially a year and a half of injections, a 6-level improvement to mild non-proliferative diabetic retinopathy. Incredible. Okay, Dr. Kim, are you there? Because we run into about 75 to 80% of patients will reduce their edema. They'll do very well. They'll see better. They're looking great. But we run into this problem. People come in with diabetic macular edema. They get a series of anti-VEGF injections. And yeah, their edema looks better or the same. Their vision is similar, but it's not what we really wanted. So Dr. Rosa Kim, are you there?
I'm here, James.
So this is your patient. Let's say I'm gonna make up, this patient is 55. They work for HISD. They are 20/50 in this eye before injections when you first saw them initially. They're severe non-proliferative diabetic retinopathy, let's say. You have given them 3 or 4 injections and they still look like this and their vision's about the same. What can you do here? What do you want to do? What are you thinking?
So a couple of points here, James, and you kind of hit all those main points about what they have to do to control their overall diabetes. I think that's foremost the key point here. I often check their blood pressure to make sure they don't have malignant hypertension, because as you all know, when their blood pressure is really high, it is very difficult to treat diabetic macular edema. So I'll check their blood pressure and counsel them what they need to do. Now, after trying one VEGF agent for 3 to 5 times monthly injections, if I get some response, I may continue for 2 or 3 more times. If I get no response, then I would soon change to another VEGF agent. I think you've mentioned this patient's vision was 20/50, so I would definitely make sure to try Eylea, because the studies by NEI has shown that Eylea, patients receiving Eylea tend to do better, well, they did better than patients receiving Lucentis or Avastin. So if they have not been tried on Eylea, I would try Eylea. And if Eylea doesn't show a significant benefit, then as your slide shows here, I would try the steroid, because we cannot forget the inflammatory component of diabetic macular edema.
Great.
So either Argedex or other implants
Yeah, thanks, Rose. And we do try steroids in these patients. They do work very well sometimes on people that don't do well with anti-VEGF for diabetic macular edema, but always, of course, we worry about cataract formation, and we watch their IOP. And there are 2 approved drugs. Ozurdex is one, and Fame or Luvine, which has a Fame was the study of Luvine is the drug, which lasts a very, very long time. They're both little small steroid-releasing implants that we can do into the eye. So let's change gears and really focus a little bit on macular degeneration. So obviously there's 2 forms, and we'll go through this quickly. Dry and wet, 80 to 90% is dry, but it's responsible for some of the vision loss, but the number of dry is increasing, and the way we treat it, or trying to treat it, Dr. Wyckoff will go into. And then the wet is the sudden, quote, what patients call the bad kind, and it's found in about 10 to 20%, but it's responsible for most of the vision loss. And this also is treated with anti-VEGF therapy. What are the risk factors? Just like it sounds like, age. There's a 17-fold increase of AMD in comparing young to old in study groups. So age by itself is a risk factor. Smoking, as I mentioned earlier, smokers have a 2.4 relative risk rate of getting wet AMD. And it's, you think about it, smoking is like oxidants. So they take vitamins, which are antioxidants. So I always say, look, smoking is like adding fuel to the fire. Wet AMD, dry AMD, it's exactly what it wants. If you want it to grow, you want it to bleed, you want it to get worse, that's what smoking does. And then genetics have come into play too. Complement factors. Dry AMD, I'm really not going to touch on this too much because we know about drusen and their size. There's also areas of geographic atrophy. That's the more severe form of dry. Dr. Wyckoff is going to hit on geographic atrophy. I think Dr. Benz is as well, on what we can do about dry, just eating away at your retina. That is the more severe form of dry. And so we'll talk about that to come. Again, drusen, you can size the drusen by looking at the size of a vein coming out of that nerve right about here, can show you, is this small or medium or large druse? Intermediate AMD is, which should by definition take vitamins, is extensive intermediate or any single large druse about the size again of that vein crossing that optic nerve. 5-year risk. This is very easy and it sounds simple, but we use it all the time. So Ms. Johnson says, I don't know what to do. Am I going to turn, I've got the dry and all these drusen, am I going to turn wet? Remember, for each eye, there's 4 points total. 1 point for drusen, 1 point for pigment changes, pigment abnormalities, and 2 points if they're wet. So their risk of turning it into advanced AMD over 5 years would, for 4 points, be 50%. For 1, it's 13, and it just keeps doubling. Geographic atrophy we'll discuss. So here's a typical patient. Comes in with wet AMD. This looks sort of chronic. They've got some XH. You can see the subretinal hemorrhage there. You get an FA. We treat them if you can see the late leakage on FA. They leak. We treat these patients with anti-VEGF that we've discussed. And hopefully they go from intra and subretinal fluid that dries up and their retina looks flatter, nicer. The interval is determined, as we mentioned earlier, by the response to the drugs that we have, but that's currently what we do, and it's a chronic condition. This is a new drug that is Dr. Wyckoff will discuss, that is called brolucizumab. It's had some hiccups, but we did recently have an FDA approval, and Dr. Wyckoff will hit on this because this is a pilfered slide directly from one of Dr. Wyckoff's previous talks. And the reason I stole it is because it's a prelude to his talk. In a second here, I'm going to kick it over to him. I have spoken about the past and the present of the bare bones of sort of diabetic retinopathy, diabetic macular edema, and wet and dry AMD. But Dr. Wyckoff holds the future in his hands. So he will discuss, what are we doing? Instead of just injecting people over and over, or the patients that don't respond, what can we do down the road? And what are we currently starting to do research-wise to really, really help these patients? Dr. Wyckoff, I'm going to kick it over to you to tell us about the future.
Thank you, James. That was a great lead up. So over the next 15 to 20 minutes, we're going to go through 3 chapters in the future of retina. and the data that's driving it towards those futures. There have been some awesome questions in the chat. One I just saw before I had to close the chat. Hopefully my partners can take over some of the chat questions that I was engaging with, but it was gene therapy. And we will finish on gene therapy. Dave Brown is going to come in and give a little primer on gene therapy because there's some really exciting data there. Probably the most exciting thing I have to say is gene therapy. But let's take each of these chapters in turn. The first one is to talk about geographic atrophy. This is by far the largest unmet need in retina, in my opinion. And Matt, this is a patient that you and I have shared on the north side of town. We'll leave his name out of this, but we have sort of taken turns seeing this gentleman. They happen to have wet AMD in the right eye, and this is their left eye. And over the last decade, you can see the changes here on the near infrared image on their OCT. Matt, tell us sort of what a patient like this is experiencing over this decade and what your conversation with them is like in clinic.
Sure, absolutely. So first of all, I agree with you completely that this is probably the biggest unmet need in our treatment of retinal and in particular macular diseases these days. You know, we have had amazing success with anti-VEGF agents, and we've been able to really control the neovascular process. And so in the past, we had these patients that ended up with these big fibrotic scars centrally with poor vision, you know, 2,400 counting fingers. You know, patients now who are treated appropriately and early with anti-VEGF agents don't end up like that. But they can still have progression of geographic atrophy, and that's a very frustrating thing for us and for our patients for sure. So these patients may sometimes retain some central foveal function, and so their visual acuity when you measure it may be still reasonably good. It might be 20/25, 20/30, but they'll complain about lots of different things, and they'll come in and they'll say, "But doc, you know, my vision's getting worse. I'm having trouble reading. I'm having trouble, you know, doing the things that I want to do." So it's really it's very, very frustrating for us. We know that there is hope on the horizon, and there's certainly been a tremendous amount of work that we are, you know, we at RCH, but we as a retina community as well, have put into trying to find, you know, new treatments, new hope, new therapies for geographic atrophy.
Great summary. And to bring some data into that, there's quite a few trials now. This is a prospective one, the largest one to date, looking at these patients longitudinally and echoing what Matt says. On average, these patients, while we think of this as the quote unquote slow progressing disease, on average, they lose about 1 line of vision every year, 5 letters at 1 year, 10 letters at 2 years, 15 letters at 3 years, and it is progressive and unrelenting. This is what it looks like clinically in your clinics and in ours. The OCT shows complete loss of the RPE band, the overlying photoreceptor band, or the EZ zone in particular, with increased reflectance through the choroid because you're not getting absorption of the OCT light by the RPE and photoreceptor bands. On the color fundus photograph, it's often the hardest to pick up, but this is sort of the region down here being shown to be atrophic, which expands over time. And then autofluorescence, if you have that imaging capability, is often the best way to image these outside of OCT and is what we use from a research perspective primarily. So this is a big topic, what's causing AMD, because you can't really treat something until you know what's causing it. And we think genetics here is one of the keys. So there's over 40 genetic loci that have been implicated in the development of geographic atrophy, and they account for probably 50% of your risk and my risk. And what's interesting is they're spread evenly, really, across most of our chromosomes. If you look at the bottom left here, there's only a couple chromosomes that are spared, and most of these genetic loci are found within complement components. And what's interesting, if you look at the functional impact of these mutations or alleles, you see that most of them actually increase the activation of the complement cascade, therefore driving an inflammatory reaction that we believe is slightly greater than normal over the course of a lifetime, leading to slow cellular breakdown, manifesting as end-stage geographic atrophy. So how are we approaching this from a treatment perspective? Well, most shots on goal involve this complicated involuted pathway called the complement cascade. And I want to try to simplify it because you're going to hear a lot more about this over the next decade, I believe. 3 major steps: C3, C5, and the MAC complex. And there's only two things this complement cascade does. One is it leads to cell death with the MAC at the bottom. And secondly, it drives an inflammatory response with the breakdown components of C3 and C5. So this is where it starts to be headache inducing. Here are 9 different medications that are being pursued to modify this pathway, most targeting C3 or C5, but there are some medications in here that are looking to increase actually the efficacy of native proteins that downregulate the activity of this pathway. So incredibly complicated. But there's not just molecules in development looking at complement inhibition. There are many molecules also looking at non-complement targets. Some of the furthest ones down the road I've listed in purple on the left. So the 2 data sets here over the last 1 to 2 years that just got published in Ophthalmology, we were a big driver behind this study that have really galvanized this field and are driving a lot of interest in this research, was this graph here. It's a simple graph, and it shows that without treatment in gray, you have progressive growth of your lesion of geographic atrophy, progressive blindness that we're all used to seeing for generations. In orange and dark orange, you see a slowing of that growth. And it looks relatively minor, 20 to 30%. But remember, this is over just 12 months of treatment. The thought is that if you continue to dose these eyes, you will continue to flatten that trajectory of geographic atrophy expansion. One of the unexpected side effects of this program, looking at a molecule called APL2, was an increased rate of development of wet AMD when treating geographic atrophy, something that we're actively investigating. Another program has validated this data looking at a different drug. This is a drug called Zimura, which is blocking C5. The first one blocks C3, this one blocks C5, and you see a very similar magnitude. With treatment, you're getting reduction in growth through a year of about 30 to 40%. Of interest, this program had exactly the same findings, an increased rate of development of wet AMD when treating geographic atrophy. So there's hope on the horizon. At the earliest, these molecules will be available commercially in 1.5 to 2 years. So it's still a ways out, but it is incredibly promising. It's never been this promising in the past. Okay, our second chapter. Let's dive into diabetic retinopathy. We all know that there are obvious thresholds for which we would initiate treatment for diabetic retinopathy. DME with vision loss, as Dr. Major, Dr. Fish, and Dr. Kim just went through, and then high-risk PDR, active bleeding. All of these eyes need treatment today. But there are a lot of thresholds in diabetes which are more complicated and allow for room for debate. For example, non-center involved DME, Dr. Major mentioned focal laser. This might be a perfect candidate for this. Center involved DME without vision loss, and even some cases of stable non-high risk PDR. But Encore, I'd love to hear your perspective on eyes like this. This is the most common form of diabetic retinopathy that we and all of our optometry colleagues see on a regular basis. These are NPDR eyes without center-involved DME, and most of these eyes are asymptomatic. What do you think about these eyes? Are you treating them? What's your conversation with these patients like in clinic today?
Got logged off.
Oh no, Encore got logged off. Dr. Scheffler, do you want to comment about what you would do with these patients?
Sure. I mean, I think that the main point to be made here is that if we were having this conversation, let's say 10 years ago, I think we'd all agree that we would have said, we'll just watch and basically wait for the patient to get worse. And, we don't necessarily have anything great to offer. And the kind of general approach that research has supported taking over the last, I'd say 5 years, is that more aggressive treatment earlier is better. Patients clearly do better, both in terms of DME development later on and non-proliferative and proliferative diabetic retinopathy later on, the earlier we treat them. So in addition to encouraging, aggressive blood sugar control on their part, of course, we watch them more closely and initiate therapy earlier than we would have, let's say, 10 years ago.
Great comments. Absolutely. So, and the sort of core data that supports that, we'll get to on the next slide. And this is just an example of what Dr. Scheffler is describing. These are eyes with high risk NPDR, lots of hemorrhages that we all see, both of these completely asymptomatic patients. You dose them a few times with really any of the anti-VEGF agents, and it truly is miraculous how these hemorrhages resolve. So the data behind this is driven recently by the Panorama trial, which we as a group were heavily involved with designing and executing. And the core data is shown in these 3 bars. So the gray is observation or sham treatment. This is the natural history. When you observe these high-risk NPDR eyes, 40 to 50% will develop PDR or center-involved DME over 1 year, compared to about 10% with anti-VEGF dosing, a relative risk reduction by 70 to 80%. So in many cases, we are starting to treat these eyes, or we are at least having a conversation about treating these eyes and then watching them closely, as Amy well described. The last topic to talk about is how are we pushing the envelope for improving efficacy and durability with new products? Okay, so here are a whole list of anti-VEGF agents that are coming up, right? Brolucizumab was mentioned by Dr. Major. This is now an FDA-approved product as of the end of last year. Abicipar just finished phase 3 trials. Both of these drugs are really exciting, except for the fact that they each have a lot of associated inflammatory problems. And I use the word a lot vaguely there because the numbers actually are relatively small for both drugs, but the problem is the safety of our current pharmaceuticals is so good that it's challenging for a medication with an inflammatory challenge to break into the market. So there's a lot of ongoing research about how we can best use these medications because they do appear to be better drying agents than our current therapeutics. But of the other 3 that are listed up here, the one that I would love for Dr. Brown to be able to comment on is KSI 301. Dave, are you on the line?
I hope so. Can you hear me?
Yeah.
All right. So KSI 301 is a really novel anti-VEGF. Before, we try to get smaller and smaller, and it turns out that small molecules go away from the vitreous and retina pretty quickly. And these guys came up with a pretty novel idea. They decided to put the anti-VEGF in a bigger molecule so that it sticks around longer. So it's a single injection, but you have much longer duration, potentially up to 6 months. And that's being tested right now in both diabetes, macular degeneration, and retinal vein occlusion.
Great summary. It's an exciting molecule that's entering multiple phase 3 trials and really all of the exudative diseases you've heard about. The second topic to talk about are devices. So the port delivery system is a surgical device, and Tian in many ways is our surgeon extraordinaire. We all operate, of course, but Tian loves to operate maybe more than the rest of us combined. Tian, tell us about this approach.
This surgery isn't really all that interesting, but it's a relatively straightforward extraocular procedure. But what we do is create an incision in the sclera about 4 millimeters behind the limbus in the area of the pars plana. And what we see here, you're basically lasering the choroid so that you don't get bleeding, which is one of the major complications of the initial surgeries that we did with this device. And then after you achieve hemostasis by lasering, then you enter the vitreous cavity, a small 3.6 millimeter blade, and then you insert this device, which is a titanium silicone implant into the supratemporal quadrant. And it requires no suturing. You just basically put it in and it fits into your incision, has an overlapping lip, and then close the conjunctiva over it. And what it does is it allows us to put in a drug that we're all very familiar and comfortable with, Lucentis, and not have to fill it, not have to do it every month. With these devices, it's about every 6 months. And actually, I think the median half-life is about 15 months. So there are some patients, half the patients don't even need a refill for some period of time. And that's for wet AMD, and we're going to be doing studies for diabetic retinopathy and diabetic macular edema. We are started diabetic macular edema already.
Yeah.
So.
Yeah, exciting technology. Good. The third of 4th boxes, and the 4th one is gene therapy, so stay tuned, is new targets. This one actually, from my perspective as a PhD in molecular biology, is maybe the one that I'm most interested in because we've been so addicted to VEGF biology for the last 20 years. But I do believe that other pathways are relevant to these diseases and will eventually get us to a point of combination therapy. And the only one anywhere close to prime time is looking at angiopoietin 2 blockade. So this is a bispecific antibody on the bottom left. There's been a lot of talk about antibodies and antibody testing given the COVID environment. This is what an antibody or an IgG looks like. There's an Fc domain, which is a constant domain, very similar for all of our antibodies that are IgG. And then most antibodies have sort of sister arms that are identical. In this case, this is an antibody that was engineered to have two different arms, or essentially Fabs. And what these are is this arm will block angiopoietin 2 and inhibit its activity, and this arm will block VEGF-A. In other words, you get blockade of both molecules with a single drug here called faricimab. A lot of details on this slide, but the key is that it looks like faricimab may be able to do better than VEGF-A monotherapy blockade. And at the top left, you see a 35% increase in visual acuity gain among this patient population of DME eyes. At the bottom, you see approximately a 30 to 40% improvement in retinal drying with the drug. And at the top right, you see approximately a 40 to 50% increase in the durability of the drug from 2 to 3 months. So this is in phase 3 trials. We're actually going to have data by the end of the year in wet AMD and DME, possibly into early 2021, given the COVID environment, to see if this has worked in phase 3 trials. If so, this would likely be commercially available approximately 1 year from now. So the last topic, and the most exciting, I think, for all of us, is the concept of gene therapy. Gene therapy is being applied broadly across retina, from ocular oncology trials that Dr. Scheffler is running to multiple exudative retinal diseases. Here we'll talk about the wet AMD approaches. Dave, if you're on the line, give us a rundown of the 2 programs that are in clinical stage development at this time.
Yeah, hey, Charlie. There are some incredibly exciting things happening. Fortunately, we've been very lucky to be at the forefront of both. There are 2 companies, REGENXBIO and Adverum, both of which Charlie and I helped design their trials and have been paramount in going to the FDA and figuring out how to get these things approved. Essentially, with gene therapy, which sounds scary, you're taking a virus which has been neutered, but it has the capability of infecting a cell, and then as its deleterious effect, which is actually a positive effect, creating a construct protein. And with the Adverum O22, which is an AAV variant, it creates Eylea. With REGENXBIO, it creates a version of Lucentis. And so basically, you're making your own factory of cells within the eye that then produce injections. So Dr. Wong and I don't have to keep injecting every month. The Adverum is very exciting. Let me start about the REGENXBIO first. It was a subretinal injection. That's a lot of fun for us that are subretinal surgeons. I developed the subretinal injector. Unfortunately, for surgeons and not for patients, it turns out that there's variability in where you put the subretinal bleb. And so now they're going suprachoroidal, which is you see on the bottom. It's into the wall of the eye, but it goes all the way around. And it may be a way to give the gene therapy vector without having to go into the eye with vitrectomy and create a subretinal bleb. That is the current way REGENXBIO is pursuing. Let me go on to Adverum. Adverum has an intravitreal injection, just like we give on a monthly basis. But with this, it's a one-time deal. You inject, and the eyes start creating anti-VEGF. And if you followed Adverum stock, it just got a huge boost as we presented our latest data that shows that many of these patients have ongoing VEGF and don't need monthly injections. We're excited about this. It's the beginning, but we're in human trials and we're making good progress.
And Dave,
anything more you want me to share there, Charlie?
Yeah, Dave, here's a surgery that we did as a group. Walk them through what the surgical procedure, what the major steps are.
Yeah, so this is the REGENXBIO surgery. Here we're doing 3 ports just like we normally do for vitrectomy. Here you have a removal of the vitreous. There you see in the middle that central choroidal vascular membrane, that wet macular degeneration. Here, Charlie is injecting with the injector under the retina. You can kind of see the blister. This is the second blister. If you watch closely, you'll see it balloon up. Basically, that's injecting a solution with virus that then will infect the RPE retina above it to create the factory that makes the anti-VEGF. Here he's going to air and very eloquently showing this patient after this never needed another injection. Very positive, dried up. It's basically a one shot and you've got all the shots for the rest of your life. It's not this easy. Please don't go out and buy Regenxbio Bio or Adverum stock based on what I'm telling you now. We're early in the game, but it is very positive, and this data has been presented other places.
Thanks, Dave. It is exciting. We've been very fortunate to treat now many patients in both of these programs, and it really is transforming how we think about this disease with a very, very bright future. Exciting times. This is my last slide from a research perspective. We at Retina Consultants Houston are incredibly privileged to share the care of your patients from a retina perspective. We do view it very much as a partnership. We do retina and retina only. We are passionate about what we do from both a clinical perspective, a surgical perspective, and a research perspective. We want to give patients the very best care that we can today, both in the OR and in clinic, regardless of the pandemic that might be enveloping our lives. But then, more importantly, from my perspective, we want to be there to give them the very best care tomorrow as well. So to advance that mission with you in partnership is really a privilege and an honor. And with that, I will pass it back to Dr. Major.
Okay, let's see here. Thank you so much, Charlie, Dave, Matt, everybody, Amy. I thought this was a great CE. You know, we can do, if you, please give us feedback about this CE. Was the Zoom okay? Did you like it? Can we do more of these in the future? You know, we'd like to do live CEs in the fall and winter, but as Charlie said, we don't know what the future holds in the COVID era. So if we need to do more of these and they're convenient with you and your schedule, we'd be happy to do them. But it really truly is, again, as Charlie said, truly is a privilege to be able to take care of your patients that you entrust to us. So thank you for coming tonight. We'll have a question and answer afterward, which we're doing right now. We want to make sure that you get your credit. So CE credits, if you read there, if you completed your registration on Eventbrite, you're definitely all set, no problems. You get 1 hour to the Texas Optometry Board. And then any questions whatsoever. I couldn't get my credit, or I logged out or something. I want my credit, or I want more of these. Please give us a feedback of any type to the email, Sarah Barbatano at below. It's rch.doctors@houstonretina.com. So any problems with getting with what we should do in the future, what you liked, what you didn't like, and how to get your 1 hour therapeutic hour, just please contact us. But should we be all set? Is there anything else? Okay, we'll open it up to questions and answers because we definitely want to finish on time. Any questions?
There was a hand up, Dr. Major. There was Tammy Graham has a question.
Let me find how to do that. I need help on how to.
Hung, can you activate?
So a good question from Annie. Good question from Annie Sue while we're pulling it up about the headaches from the mask and the Clorox. The masks are tough, right? I mean, especially the N95s, it's kind of hypoxic. My personal thought from a lot of work is that you're better off wearing a non-N95 if you can keep it on all the time. If you can keep an N95 all the time, hallelujah, it's really tough. I've switched to sort of a higher class non-N95, and we put the patients in them as well, which I think is sort of double protection. You're keeping their viral particles away from you, and you have another barrier. But still, if you can't wear the N95 and you take it off and on, you're defeating the purpose.
Good. Let's see here. Any other questions? I'm trying to find questions here. Show me. Let's see. I'm scrolling through other.
So there's a lot of questions about.
Yeah,
there's a lot of questions about CBD, right? That is an area that there is actually a lot of NIH research, but no real data out yet to comment on. And so it's possible it will be helpful, but at this point, unless Charlie or one of the other panelists has been part of symposiums or whatever that I haven't been on, it's still a work in progress.
I see a question there about blood sugar monitoring devices. It's a great question. And I think for patients that can handle it, the continuous glucose monitors that are continuously monitoring glucose systemically have been a game changer for a lot of my, especially younger type 1 diabetics that are brittle. So encourage your patients, if they have access to an endocrinologist, to ask about continuous glucose monitoring versus these sort of random checks that are sort of historical at this point.
My wife is an endocrinologist. I'll second that. She says the same thing. It's absolutely true. You see a lot less diabetic retinopathy in those patients.
Good question about AI also. There's a lot of work going on with AI. We're heavily involved in that research, right? The hope is to be able to get much better diagnostically and prognostically with patients. So there's technology being developed that will overlay some of your software programs eventually on your OCT and your Optos that will direct your attention to what the pathology might be and help you sort of indicate what a diagnosis might be, right? These technologies cannot make a diagnosis, but they can suggest and indicate where you might look and what you might think about. Sort of similar to what the radiologists are using today in many institutions.
So a great question from Holly Groff about, I think the hardest part of examinations where they're fogging up because the mask we have on the patients is fogging your 90 or 78 or 28. If you really need to look, you have to put surgical tape over the nose. I also, when I'm doing an indirect, I just don't breathe when I'm doing it because otherwise it fogs me as I'm, looking in. So it's certainly a challenge. If you have an Optos, we get photos before that gives you another shot on goal at seeing some of the peripheral retina that you may miss because of the fogging.
Okay, I think the hour has come. RCH doctors, optometrists all over Greater Houston. Again, thank you so much. Everyone stay safe. And if there's anything we can do, please email us at email as below. Thank you all for coming, and we hope you learned a lot.